we are going to talk about one of the most fundamental concepts in mathematics, and let's take a look how it is applied in our current situation today. We have here the cumulative confirmed COVID-19 cases, but do take note that these confirmed cases are lower than the number of actual cases because of limited testing. So, we can see here a graph. Probably most of us are familiar with graphs already as we have encountered them in high school and even in social media, internet, and in other forms of communication. So, do take note that these are the information for this specific graph. It's from January 19 to June 29, 2020, and it starts at January 19 because it's the first day since the 100 confirmed case. So, here below are the days since the 100 confirmed case, and that's January 19, and here are the number of cases. So, as you can see, let's take a closer look. Here at the start, after the 100 case, it's labeled 111 cases, and as you can see, the line goes up. At the 20th day after the 100 case, we have a specific value here which is in between 2,000 to 3,000 or 2,000 to 4,000 cases. So this specific part here or this specific point here of the graph, when we're going to draw it, it corresponds to two numbers. The number of days at the bottom and here the number of cases on the left. Same here. This 3,000 plus cases here corresponds to a specific day that is in between 20 to 40 days here. And as we go up to our line, it shows that this drawing is formed by pairing the number of days to the number of cases that we see here. So, taking a look again wholly at our graph, we can see that the reason why the shape of our graph is this is because we are pairing the number of days and the number of cases. Let's take a look at some other graphs. Here we now have the graph of Indonesia. It looks like similar to the graph of the Philippines, it's just higher, which would mean that their numbers are higher in the number of cases, even though it's still the same number of days. And the reason again why the shape is like this is because of the pairing of the number of days to the number of cases. Let's take a look at some more graphs. Here we have the graph of Singapore. As you can see here, for Singapore, it looks different than the graphs of Indonesia and Philippines. It looks like it suddenly bent downward as it goes further the number of days. And why is that? Do take note that it looks like it's going up, but here it started to go down. So that even though we're going to the right, the number of cases is not actually going up, but actually going downward. That's why the shape looks like it's bent. And again, the reason for this shape is because we are pairing the number of days to the number of cases. Now we have the graphs of two countries that are known for effectively handling COVID-19, South Korea and New Zealand. As you can see here, in the South Korean graph, it rose up, but then it becomes flat, flat, flat. It's not that rising up. Their numbers are just between 10,000 to 20,000, although that's still a lot, but that is lower compared to these countries. While New Zealand did not even reach 10,000, they remain flat here below. Although it might still be a lot, but that is less than 10,000 because the numbers here on our vertical line are 10,000. And again, the shape of these drawings, of these graphs, is caused by the pairing of the numbers here below on our vertical side, on our horizontal side rather, which are the number of days, and the pairing of our numbers and the vertical side, which are the number of cases. And these pairings of numbers are represented in mathematics in a creative system called the rectangular coordinate system or the Cartesian plane. And we're going to learn more about the rectangular coordinate system and the Cartesian plane in the next video.